Alright, so this is problem 3A on the study guide, unit 2. This is the first 3A, not the second one. This is the fourth time I'm going to solve this problem. For some reason it is not working repeatedly. I don't know why. This problem is cursed, but we're going to try again anyways. So the problem says this polynomial, we want to find all the zeros of it and sketch the graph of the curve. We're given the hint that x minus 2 squared, that kind of looks like a squared, x minus 2 squared divides into the polynomial. So we can rewrite it as x minus 2 times x minus 2, because that's what squared means. And we can see that really we have two linear factors here. So you have options. You can FOIL this out and get a quadratic and use use long division to divide by that quadratic. Or, in my opinion, the easier route is to use synthetic division twice. So again, for synthetic division, you take your 0, so 2 in this case, and then you go ahead and write in the coefficients on your x terms. So negative 1 plus 6, I don't want that plus there, but positive 6, and so negative 1, 6, negative 9, negative 4, and positive 12. So first step, drop that negative 1 down. 2 times negative 1 is negative 2. 6 plus negative 2 is 4. 2 times 4 is 8. Negative 9 plus 8 is negative 1. 2 times negative 1 is negative 2. Negative 4 plus negative 2 is negative 6. 2 times negative 6 is negative 12, which makes us happy because that means we get a remainder of 0. So now we can go ahead and do the same thing again with our new polynomial. Negative 1, 4, negative 1, negative 6. And same thing, drop that negative 1 down. 2 times negative 1 is negative 2. 4 plus negative 2 is 2. 2 times 2 is 4. Negative 1 plus 4 is 3. 2 times 3 is 6. And again, we're happy because we get a remainder of 0. So we can write the quadratic that we just found as negative x squared plus 2x plus 3 multiplied by those two linear factors, x minus 2. I'm just going to write it like that. But again, anytime we have a quadratic or any polynomial, I'm always going to try and get a leading coefficient of 1 if possible. So I'm going to factor that negative out of that x squared. So I'll factor that negative out. I'm left with x squared minus 2x minus 3. And then we have x minus 2 squared. So we can factor that now, negative. And we can see we want two numbers that multiply to give me negative 3 and add to give me 2. So I'm going to use negative 3 and positive 1. We can check it. 1 times negative 3 is negative 3. Negative 3 plus 1 is negative 2. So I'm good. And then I have my x minus 2 still. Okay, to graph this, again, we want to start off by looking at end behavior. So to do that, we look at our x term with the highest degree, which in this case is written in descending order for us, so we're happy. X to the fourth, so it's an even degree, and it's a negative coefficient. So that tells us it's going to behave like negative x squared, which looks like that, goes down and down. So all I have to do really is throw my zeros in there, which my zeros are at x equals 3, negative 1, and 2. And I'm going to put a box around the 2 because that's special. It is of multiplicity 2. We'll look back at that in a moment. Okay, so let's go ahead and get some axes labeled. And my zeros are at x equals 3, negative 1, and 2. So, scroll back up. We said it's going to look like a negative x squared graph, like that. So I know that my end behavior is down and down. So I'm going to start on the left. I'm going to be coming up to that first 0. First zero is -1, which corresponds to that term right there, which is multiplicity 1. So it flows right through the graph, curves, comes back to my second zero, which is at +2, which corresponds to that zero, which is multiplicity 2. So it behaves like a quadratic. So it's going to hit it and bounce off. So it's going to go whoop, bounce back up, curve, come back down, hit my last zero, which is at x equals 3, corresponds to that factor, multiplicity of 1. So it's going to fly right through the graph and go back down, which agrees with the end behavior we said it was going to have. And we are done. And please, hopefully this video will work this time.